Here we have sample question number 19. This one not only wants us to graph, but it also wants us to find three ordered pairs. So again, graph first, shade. Once you shade, then you can grab any point that is in that shaded region. Don't grab a point that's on the boundary line. Just grab any point that's in the shaded region, and that would be a solution. So how do I grab a point from the shaded area? We have to actually graph and color in to figure out what is the shaded area. So let's graph this guy. Remember, we went through the steps. It's 6 steps to graph. Step 1, pretend it's an equal sign. Okay? So this was the original. We're going to pretend it's an equal sign. When you pretend it's an equal sign, that will help you find your boundary line. Second step, ask yourself, is y by itself? No. We need y by itself because we can grab the constant and we can grab the coefficient of x to know the y-intercept and the slope only when y is by itself. So not by itself, so I have to tweak. How do we tweak? Remember, underline the y. Is anything added or subtracted? Yep, this 4x is subtracted. Move the 4x, so the opposite would be subtract 4x on both sides. These cancel out, so you have negative 7y, and then a positive 21 and a negative 4x. Yeah, you cannot combine them. They're different. Remember, constant, coefficient, variable. So I put the variable term first, and then constant term last. Then, get rid of the coefficient. So divide both sides by negative 7. Negative 7. Negative 7, and negative 7. Remember, because there's 2 items over here, I divide both, not just one. These cancel out. Negative divided by negative is positive. 7 divided by 7 is 1y or y. Negative divided by negative, remember simplify, you get a positive. 4 divided by 7, that gives you a decimal point. So leave it as 4 sevenths. We can't reduce this any further because 7 is a prime number. 4 you can break down as 2 and 2, but it can't cancel out with a 7. So 4 sevenths is the best you can do for the fraction. Notice the x is on top, so we can slide it over. Anytime it's on top, you're allowed to slide over. If it's on the bottom, for any reason, you're not allowed to slide over. You have to keep it in the fraction bar. And then here, positive 21 divided by negative 7, you're going to get a negative 3. Okay? Now that we have this, step 2 is done. Step 3, tell me what the y-intercept is, tell me what the slope is. Boom, that's your y-intercept. So write it as an ordered pair, 0 and whatever the constant is, negative 3. This is your slope. Boom. There's your third step. Fourth step, graph your y-intercept. So find 0, negative 3. Boom. Why is it down here? Because I told you, it has to be on the y-axis. If you find x is 0, you know 0 is right here. And then since it's a negative 3, go down 3 units. 1, 2, 3. Okay, so that's the 0, negative 3 that we just found. Okay? Fifth step. We got to get another point. You need more than one point to graph. Because I don't know if the line's going to go like this, or like this, or like this. So we need to find our next point. We told you it's based on the slope. Make sure the slope is written as a fraction. Perfect. 4 over 7. There's no negatives that I have to put on top or bottom, so I'm fine with that. So remember, the top number tells you up or down. If it's positive, it's up. The bottom number tells you left or right. If it's positive, you go to the right. Again, if it's negative at the bottom, then you go to the left. So, where do I start the up and right from? Not here, not out here, always from your y-intercept, here. So from here, go up 4 units. 1, 2, 3, 4. And then go to the right 7 units. 1, 2, 3, 4, 5, 6, 7. Boom. Now that you got 2 points, you can connect. Okay? You could technically, from this point, get a 3rd point by doing that same pattern. I can't because it goes off the board. But you could keep on going from each new point up 4 units over 7. Up 4 units and then over 7. And you'll still get that nice line. So now we have at least 2 points we gotta connect. That's step 6. But are we doing it as a solid line or dotted? Look at your original problem. Notice it's not underlined, it's just a plain less than. So this one means we're gonna do dotted. So as best you can, dot the line. See how it's dotted? Not one solid line? You are done graphing the boundary. Now just because you have the boundary doesn't mean you're done. You have to do shading. When you have inequalities, you must shade. So am I going to do below this dotted, or am I going to do above this dotted line? This is where you have to grab a test point. So step 1 in shading was grab a test point. Any point that's not on this purple dotted line. So don't pick this 0, -3. Don't pick this point 7, 1. Pick something like 0, 0. Not on the purple line. You can be on the axis. You just can't be on the boundary line. So I'm going to plug in this test point to determine true or false. So step 2. So we know that we're going to test 0, 0. That's our test point. Our original problem was 4x minus 7y is less than 21. So every time I see an x, parentheses, and anytime I see a y, parentheses, and then plug in. X is 0, y is 0, and then distribute. This times this, 0. This times this, 0. 0 minus 0, 0. Now ask yourself, is that a true or a false statement? Alligator already made up its mind. Wants to eat the 21. Let's see if we're in agreement. Would I rather have $0 or would I rather have $21 in my pocket? Yeah, I'd rather have 21. Alligator also picked 21. I'm picking 21. Remember how the alligator decides? It eats the bigger one. So if it's eating 21, that's how it's deciding it wants the 21. I want the 21, so we're both in agreement. So this is true. So where my test point is. Step 3. We put a T here. Why? Because we got a true. If this said false, then I put an F where my test point is. And my 4th step, shade in the true part. If this was false, then you have to shade down here. But since this is true, I know this is false. Don't shade false. Shade only the true side. Make sure you blow past this y-axis and this part of the x-axis. The only thing that bounds me from going over anything is this dotted purple line. But anything above it is fair game to shade in. Okay, we're not done yet. Remember, this asks us to graph, but also give us 3 ordered pairs that are solutions. So let me erase so I can make some space. We'll just erase this purple stuff. So you need to, on the test in ALEKS, they're going to give you these parentheses. You got to plug in values. Order pair 1, order pair 2, order pair 3. Again, don't pick anything on this purple line. Pick anything in this red shaded area. Like 0, 0. We just saw that if we plug 0, 0, we get a true. That means it's a solution. 0, 0 would work. Anything in this area would work. You know my 3, 3. Where would 3, 3 be? Yep, it's in the red area. Remember the shaded area. So that would work. 3, 3. If you want to pick this point, right? As long as it's not on this purple line and it's in the shaded area, this would be 0, comma, 5. If you plug each one of these, you're going to get a true statement. 0 of 0, we know that's right, because 0 minus 0, 0 is less than 21. How about 3, 3? This would be 12 minus 21. 12 minus 21, you're going to get a negative number. Okay, so negative 9 is definitely less than a positive 21. Or 0, 5, 0 minus 35, which would be negative 35. Negative 35 is definitely less than 21. So each one of these plugged in gives you a solution. So these are 3 possible solutions. You can get as many as you feel is comfortable. You can pick this point, this point, this point, this point, this point. Anything in the red. Okay? Don't pick anything on the white. Don't pick anything on the boundary line. Why don't pick anything on the boundary line? Because remember, this was dotted. Dotted means, and that's the difference, dotted means you can get so close to this line, you just can't land on it. Versus solid means you can land on it. That would be a solution point. So when you see dotted, never ever pick any point that's on the boundary line as a solution.